Well, here we are. Hello, good afternoon, good evening, wherever you are and whatever you're doing. I am joined today by Erich Freymann, and he's from Bird's Eye View Aero, and we're going to talk about the Firefly 6 Pro. Well, actually, you tell us about it. You tell us all about it, Erich.
Okay. Well, thanks for having us on. It's great to be able to release this new and most updated version of the Firefly 6 Pro just in time for the Interdrone convention going on in Vegas this week, as well as the new Part 107 regulations going into effect in the United States as of last week. We've released this new airframe to service our commercial customers for mapping, surveying, assessment, things like that.
Now, I see it's obviously got engines in funny places, if we know flying wings, and it's got very short wings, it looks like, if that's it hanging behind you. Plainly that isn't in its entirety.
What I have here behind me is the main base construction of the airframe. This is the one solid piece that stays together in the takedown configuration. The wings are attached like so. They slide in through nice little spar tubes, what have you, and then we have the wing tips. Again, snap onto the wing itself. The neat thing about the whole airframe is there's no tools to assemble it. Everything's magnetic, such as the way the wing tips attach. There's little magnets on there, rare earth magnets here, as well as the main wing attachment. So there's magnets on the airframe as well. So all this just basically snaps together. We have a single quick disconnect in the wing that connects the landing gear and the elevon servos to the main frame. And then
I'm seeing a retract there as well, eh?
Yes, it has retractable landing gear in the wings, and then it has a single nose wheel that comes down in the nose. And that nose wheel is actually offset. I don't know if people know about the A10, or the nose landing gear is offset because of the big gun in the front of the A10. We do the same thing to get the nose wheel a little bit out of the field of view of if you have a fixed GoPro camera or something mounted on the bottom of the plane.
And what's the wingspan when it's assembled then?
It's 60 inches, so it basically turns into a 60-inch flying wing with a little bit of a lifting body, as you can see, orientation to it. And then because of that frame dimension, we now allow the capability to mount what's basically a Y6 helicopter multi-rotor to that frame. And in that frame, we have this tilting mechanism here that facilitates the transition of the aircraft from hover helicopter mode to the airplane mode.
And are you doing that with multiple flight computers or a single flight computer?
We're using a single flight controller that is based on the PX4 Hawk, which is the old, also known as Pixhawk hardware. We're running a highly modified version of firmware in that handles all the transition, the smart wind assist, the different types of actions on waypoints, also handling the new things such as landing gear retraction, the transition, and also payload operations. All that is coupled together.
Let's unpack that a little bit then. So if I'm flying the Firefly, do I just push the nose forward and it keeps going forward in transitions, or do I flip a switch in order to facilitate the transition?
The transition is handled completely by the autopilot. So yes, it is basically a button press, and you can either wire a function on your RC transmitter. In the case of the Pro, we've gone away from the RC transmitter, and the whole thing is operated from a DS4. DualShock 4.
Does that connect directly to your existing transmitter, or has that got a TX, or does that go to a ground control station? What's the C2 link for that?
This is Bluetooth or USB wired to your laptop or Windows tablet. Okay, the RC, the traditional RC controller, your Tyrannus or whatever you're going to use, that's gone. You're no longer going to be limited by the range of your RC link. The system is completely operated through the common C2 link. In the case of the Pro, is an RFD 900 plus.
Oh, okay. Okay, so let's talk. The RFD 900 is attached to your laptop or tablet or whatever, and that's providing the radio link. So
Correct.
would I normally be hand flying it, or would I be using waypoints and on autonomous missions to actually get the job done? Why I'm going with that is, would I actually ever be handling the transition myself?
You'll never be handling the transition yourself. How and or where and when, maybe, depending on how you want to plan your mission out. It can be as much as pilot in a loop as you want through the different types of flight modes. One being out hold mode, which is basically the same as the I want to say it's similar to the APM fly-by-wire B mode,
Okay.
but obviously it's a little bit different the way we implement it through our software. That is with the Pro in this interface about as manual as you're going to get. So you have directional control, left, right, and this is for hover as well as in forward flight mode. So your traditional, what you would call a cyclic or whatever on a multi-rotor, it still functions in a hover. Okay, when you transition into forward flight mode, now all you have is left and right, and you can control altitude still with your throttle. So that's where we kind of split from that fly-by-wire B mode. Altitude control in hover and forward flight mode is always controlled by the throttle. So you don't have to make that switch in your head. Well, am I adjusting my altitude by this now, or am I doing it with my pitch stick? So it's always by the throttle. So we've taken a lot of things and kind of the whole thing about the transition is we want to make it simple so people don't have to flip switches in their brain as well as on their radios and on their computers. So since the transition is fully autonomous and just commanded either by a mission script in your flight plan, button press on your hand controller, or a button press in the ground control station software, the transition is a no-brainer. As long as you got it pointed in clear area, because since it basically takes over full control of the aircraft, there's about 5 seconds where you can't do really anything about it. You do have some limited roll control we put in there, so if the wind catches it and it's starting to head off towards a building or something, and you can nudge it one way or the other, but for the most part, the transition is fully automatic. So 1 second you're flying a multi-rotor, you push a button, 5 seconds later you're flying a fixed wing.
Well, that's like everything, isn't it? If you fly it into a tree, you are flying it into a tree. you can't get away from that one.
It will always do whatever you tell it to do. So, but to answer your previous question about how much in the loop does the pilot participate in, and again, it's an experienced operator maybe want to be more hands on it because you can do a little bit quicker launches and recoveries. Doing manual inputs. Fire it up, get it up in the air, transition it, and then hit the easy button, the auto button. Some people, especially a lot of the customers that we're interacting right now, they're surveyors, they're engineers, they're agronomists. They're not airplane people. So they want as much simplicity as possible. And so what we've done is we've added what we think is enough smarts in the airplane such that an operator can literally just plan a mission with an automatic takeoff and then a transition in the whole 9 yards right into a mapping mission, and then the airplane recover itself without any operator input.
I suppose people might wonder, well, what's the point of this? Why wouldn't I just have a big DJI Matrice or something super fabulously expensive and big? Where's the advantage in having a transitioning flying wing?
Well, one of the neatest use cases I had recently, I demonstrated for a timber company, and they do clear cuts out in pretty austere areas. And they've been flying another fixed wing, popular fixed wing, for a while, for about 2 years now, and they're just tired of repairing it because where they're at and the way it lands is basically does the skid crash belly land. Sensors on the bottom, so they're constantly pulling sand and mud out of the sensor, lens and what have you. So the traditional fixed wing doesn't really land exactly where you want it to or where you need it to, and I can attest to that. My entire career I've been dealing with precision landing fixed wings that aren't so precision.
Yeah.
And on the flip side, the multi-rotors, they have the lifting capability, and they have the capability to fly in a very precise area, but not for very long. Some multi-rotors, they're pushing up, they're advertising, I don't know what they're getting, but they're advertising 40 minutes, 45 minutes. Some of them are almost up to an hour now. But you read the fine print, either they're not carrying a payload, or they're flying in other perfect ideal conditions. So what we can do is we can take a camera that would normally be attached to a matrix or something that can carry a big Sony like this, but we can also carry this camera for 45 minutes at 32 knots airspeed, which equates to about 460 to almost 500 acres of coverage at a 2.4-inch GSD. So I would challenge anybody to find a multi-rotor that can do that.
Yeah, absolutely. Now, you mentioned previously when we started talking about flight modes of the computer, something about the wind. What can this do in the wind? Can it fly on windy days? Does it always have to fly? What does it do with the wind?
Yeah. The biggest challenge for any VTOL platform is you have essentially a multi-rotor that has limited controllability in winds as it is. Now you're attaching a 5-foot sail to it. And so the wind is going to affect that wing area at a greater impact than the 6 little motors on this multi-rotor can handle in all situations. So what we do is we've developed a technique called Smart Wind Assist. And the system is constantly checking itself and looking at the efforts it's putting out to compensate to hold a GPS position. Whether you're doing an automated takeoff or landing, or you're in the loiter GPS hold mode and flying manually, the aircraft will sense any kind of effort it's trying to push left or right or backwards and forwards. And in that, it develops a wind model and can kind of figure out where the wind is coming from. And so it automatically will yaw the nose such that it's always into the wind. So now that the nose is into the wind, we can leverage our tilting front motors. Rather than tilting the entire aircraft forward and creating a negative angle of attack, our airframe stays level and into the wind, but we rotate our forward motors slightly. And this is all behind the scenes automated on the aircraft.
Yeah.
You don't really see these happening. But instead of tilting the aircraft forward to hold position, we just tilt the motors forward. And now we have that thrust into the wind. And we can actually hover in sustained winds up to 15, 20 knots.
And let's say, I can't remember what I was going to say. I was going to say, well, so the sensors it can lift, then that was a pretty big. Which Sony camera was that you just held up?
This is a Sony A5100. Has the interchangeable lens system on it. It's like the baby brother to the next series.
Right.
The newest camera, it's basically the same body. Pretty much the same everything. I don't know what I guess they just updated software to it, but all the new birds now, when you order this package, will get the A6000. It's 24 megapixel.
What sensor suites do you have available for it, and how do they fit on? Is it just bolted on, and then how do we trigger them?
So what we've done is we've created a common payload mounting system, and they're all vibration isolated. So you see the little rubber grommets, they all have this. And like similar to like a camera tripod using a dovetail square. And so what we can do is I'll just throw this on the bird real quick.
Yeah.
So on the bottom of the bird, we have a mating plate that adapts to whatever sensor we got. So in this case, I just clip it on there, and then I would have one cable to connect to the airplane. That would be our electrical interface. So I can go one mission, I can have the Sony land, take that down, and then let's say I want to do an assessment of what I just saw. I can attach our 3-axis GoPro gimbal. and then we have that. One common electrical connector for any payload we have. So the software in the aircraft actually determines what payload it has on it, and then translates to appropriate commands from the ground station for whatever it is you're doing, whether it's a Sony camera or you're operating a 3-axis gimbal. And this is a neat little gimbal. It's based on the Tiny 2, and it actually is a pan tilt that we can control from the D-pad while we're flying using this.
Oh, you're back.
Yeah, I think I lost you, huh?
You did. Are we back?
Where did we leave off at?
It said live. Oh, clever Google. I wonder what will happen now. You were just fixing a camera on. I don't know whether that made you go away or not. So we can flick about cameras, and I noticed when you were looking at the underside of the airframe there, it looks like you've got some jigsaw cutouts as well. So is that Clever Wing sort of jigsaw onto there?
This is, are you talking about these holes?
That's the retracts, isn't it? That's what it is. Yeah,
it's where the so your wing is going to mate up right into here. Okay.
I just thought about that when I was doing it. But I like the as you said, I realized that's what it was. But I like the angling of the wings. That's going to help you a little bit with flex like this when the thing's flying. The straight edges can have issues. I know. So that's pretty cool.
Some people have, made comments that, well, aren't you worried about the wings coming off because they're only held on by magnets rather than nuts and bolts or whatever hardware? And frankly, it's, we're not doing, 640 degree per second, rolls. And another piece is that when the wing is loaded, the spar tubes are pinched, so the wing isn't going to go anywhere once the wing's loaded. So, no, we don't lose wings in flight. Nor have we ever lost any of the wingtips. and equally, you've got a multi-rotor there. So if you did lose a wing in flight, you've got another bite of the cherry for coming home. If you're quick enough on the button to hit the transition, you could. And that's another kind of a redundancy. When you think of what could go wrong with just a traditional flying wing, you only have 2 servos, the 2 elevon servos, and if one goes bad, well, you've obviously lost your ability to turn and maintain pitch control. So if this were to happen with this bird, a good operator could identify that and in helicopter mode and hover home and land. And
then speaking to that redundancy, I was going to ask that. So what redundancy does a Y6 offer against a standard quadcopter?
Well, we have 6 motors, and in my hours and hours of testing, everything's once, and I have had a motor failure on a front pod once, and the aircraft continued to hover, and it was fully controllable. I even had I was training an individual once on his bird, and we were doing an automated recovery, doing the return to land process, where you basically just command the airplane to come home, and what it does is it if it's flying as a plane, it'll just turn towards home, and 150 meters out, it will automatically transition to hover mode and then continue to the land point as a helicopter. Once it gets there, it automatically drops the landing gear, descends, and lands. Well, he had basically, his aircraft got just to the point where it was about to drop the landing gear and descend when it threw a prop off one of the front motor pods. And and I was at the control at that point, and so I just kind of monitored the situation. The aircraft didn't do anything weird; it just kind of did its normal descent, and it got a little lower to the ground, and it kind of started doing a little bit of a wobble, but it got on the ground safely, despite having one less prop than it took off with. So that's tantamount to the robustness of the controller.
Yeah, and then another thing I was thinking, so here I live in Africa, and I live up at 5,000 feet, and it's very often 30. In fact, we're going into summer now. It's the time of year when I don't go flying because it gets into 40 degrees C days. It's pretty hot, pretty high. AI can't I actually can't take it is the biggest reason, really. What sort of testing has it had environmentally, this platform?
Well, our main shop is in New Hampshire, and little trivia: New Hampshire has the coldest recorded temperature in North America history. Somewhere around minus 100 Fahrenheit or something like that. Obviously, we don't fly when it's that cold, but it gets cold enough in New Hampshire, and we don't stop flying, but we do continue test flying through the winter, well into sub-zero temperatures there. And really, the biggest issue is not have anything to do with the aircraft; it's with the batteries. You know, lithium polymer batteries. Once they get below 50, 40 degrees Fahrenheit, they just don't perform. So you keep them warm and put them in an airplane warm, and the airplane will keep them warm through discharge. You know, so that's handled. I'm down in Florida, so hot and humid. You know, humidity is terrible on adhesives and things like electronics and things like that. And I am actually the bird that's behind me here. That's Faith. That's our mean time between failure testing bird. Today she flew her 276th flight and is about 140 some hours airborne. And distance-wise, that is equivalent from flying from Florida to Nome, Alaska. So she's definitely got some time on her, and that's all since March was her first flight. And then also we had an individual, part of our team was out in the desert in California. He was flying in hot, dry conditions. And lastly, we have customers out in Utah that are routinely flying around at 7,000 feet MSL.
Oh, okay. And then is it able to carry all your payloads? That sort of.
Yeah, that customer, he is flying a modified version of a GoPro gimbal carrying a FLIR view. And also, he's also carrying the A5100 Sony.
So here I am, my shiny brand new Part 107 ticket. I'm ready to go, and I'm looking for more kit. On the face of it, it strikes me that, and I assume you've got a gimbal that goes underneath this as well. You've got here a cross between a Phantom and an aircraft, and so I could increase the range of things I could do with my airframe, particularly in the longer, perhaps ag roll or whatever needs a little bit of a larger ground survey. Is that about right?
Yeah, I mean, we don't profess to replace any of the traditional multi-rotor missions. We are a fixed wing that has the capability to take off and land vertically, and that's it. This plane is not designed to take off as a helicopter and hover around and do inspections and things like that. It's just it's a wing, right? So we just have this capability to land and take off from a little corner of the woods and go straight up and map or assess or whatever we need to do as an airplane. So technically, a good all-around piece of kit would include your light quad or hexcopter to do tight, close-in assessment and maybe even mapping missions. You know, things that are less than 30 or 40 acres. And then once you have a broader area above 40 or 50 acres, but you're still constrained as far as takeoff and landing situation, that's where the Firefly makes its money.
And are there any plans to go bigger still?
I don't know. I don't think that's on the plans for the next version. I know Adam is tossing around ideas for version 2, but that's all in his head. and so
you say version 2. Is this? There's been there was the previous standard one. Is there much of a difference between the two? And how's it got here? What was the history of this airframe?
Well, basically started out as a hobbyist, kind of a neat plane to for the FPV crowd, kind of a novelty thing a little bit. And I think Adam was looking at, because he and I both actually worked for the same company at one point, and he comes from another that featured thrown fixed wings and all these common fixed wing platforms had the same issues with how to land and how they treat their sensors. I mean, they're landing on their sensors all the time. So he wanted to come up with this bird that had the length of flight of a fixed wing, but you didn't have to throw it. You didn't have to worry about cleaning dirt out of it when you landed it. So it because of the regulatory nature that we had in the U.S., it made more sense for him to kind of develop this thing at a cheap price and market it to the hobbyists, because hobbyists weren't restricted so much.
Yeah.
So through feedback from the hobbyist community, and looking forward into the regulatory nature that we have now, we were able to test and develop what we have.
It's very cool, and I'm bound to ask, I'm a wing flying sort of a chap, just how much extra drag do those motors add? I mean, it must what perhaps it's a trade secret in horizontal flight. What sort of amp draw do you get out of the thing in standard forward flight?
Well, Adam is an aerospace engineer, and he assures me some things. At the airspeeds that we fly, like when you, let's say for example, you have this big camera hanging from the bottom of the plane, you think, well, that's a lot of drag at 30 knots. That's got to take a hit, and actually at 30 knots airspeed, something like this, or the GoPro gimbal or anything, the drag coefficient from these things is actually pretty minimal. What affects the aircraft the most out of this payload is just the weight, because this is a pretty heavy payload. The motors, the front motors, all four motors are operating, so they're all paying for themselves in forward flight. The only motors that shut down in flight are the ones on the rear, and by some interesting behavior, the rear props tend to streamline in a straight line, or maybe in a little X, but they just stop and line up with the back, and it just looks like a stingray kind of tail as it goes by. The amp draw, we're anywhere from 8 to 12 amp draw.
Okay.
In forward flight.
Another thing, I see the RFD antenna there. What about video links, real-time video links back down?
Yeah, the Pro, one of the reasons to get rid of the RC radio is we don't have that 2.4 burden, right? So for better quality and better link on the video side, we offer a 2.4 video. It's basically the Team Black Sheep 2G4 system.
Yeah.
800 milliwatt 2.4 transmitter, and if you were to opt for a Pro with the gimbal, either the GoPro or the FLIR version, the video transmitting system and the TBS base station will come with that aircraft. So now your range is only limited to your video and your 900 link. You don't have to worry about your RC radio going out.
And did I see that you've also had a go at putting the Sequoia multispectral camera on it?
Yeah, Sequoia is still in the works. Their hardware was fine, but their software was not ready for prime time yet. We did get an early production version of it. We flew it. We didn't get very good results from it. Adam is the one that was testing it, so he could be more specific at some point. But we kind of had to shelve the Sequoia, and we went full bore with the MicaSense. So as far as a precision agricultural package, the MicaSense is where it's at right now. They do have the DLS now that I have, that I started the test and didn't get off the bench with it because it didn't work. So they're basically back to the drawing board on the DLS. But just without the DLS, the Red Edge still works just fine. You do a calibration shot on it, and off you go.
And are you guys working at sort of merging data acquisition from your aircraft with other people's post-production software, getting into bed with any of the propellers or drone deploys of this world?
Our system is agnostic to post-processing. We have the tool that allows you to use a standard camera like the Sony and geotag your imagery in post. Once your imagery is geotagged, you can roll it into whatever you use. I used Drone Deploy. I've used Propeller most recently. Even Maps Made Easy. Or if you have your own Pix 4D or whatever, once the images are geotagged, you can roll them into whatever you want. So it doesn't matter if one customer uses Pix 4D on their own computers for local processing. That's great. And then if you got payloads like the Red Edge, well, that only works with Atlas, so you're kind of stuck with them anyway. Good news about the Red Edge is it geotags images for you. And Sequoia is going to be the same kind of setup. So our aircraft is processing system agnostic. So whatever you're used to using, whatever you've been using, or whatever you choose to use in the future, it doesn't matter with the Firefly.
And do you have I know I was going to ask, perhaps you got some really exotic customers doing some very fancy things. Are there any that you can actually share with us?
We recently got an email from an individual that went to Greenland, and he used a Firefly 6 to map glacier movement. So you think, well, how exciting is that? But they were up there, I guess, for 2.5 weeks, and they had to fly the glacier face every 12 hours for 2.5 weeks straight. So when you're talking about gotta go reliability, that's where it's at. And northern Greenland, it doesn't have perfect weather all the time. And for 2.5 weeks straight, 12 hours every 12 hours that aircraft flew and got what they needed.
Do you pull the pixel logs? Do you have any sort of online system so you can monitor what the customer's doing if they want that sort of aftercare?
We part of our training and in our documentation, we illustrate how to pull the logs off of them. We have some of the best, I think, customer support, because mostly it's me. You send an email to a support email, it's going to come to me, and then we'll figure it out from there. But we pride ourselves on being responsive, and any of our customers have any issues or anomalies with their aircraft, the first thing we do is we ask for a telemetry log and their data log off the autopilot. If we need to help them get that, that's fine. And then that way we can analyze everything, because basically we can look and see exactly what happened with the aircraft in most cases. So, and of course, either the customer learns or we learn. There's been cases where a customer got in an odd situation, and it was actually a bug in the software, and allows us to fix that. Sometimes it's more or less just an operational error on the customer side, and we can help them get through that.
And I'm looking at it behind you there, and I'm looking at the motors and the wiring. If I'm in the field, if I'm in Greenland, how easy is it to replace things?
It's not hard. And not unlike any other multi-rotor, really. You got your motors that are attached to the front pods. Then you'll have, in the case of the Pro, we use the Castle 25 speed controls, which most people are familiar with, and then those are soldered. There's a nice distribution board inside there everything is directly soldered. So you do have to be able to solder out in the field, because we don't like using bullet connectors, because the prone to failure, vibration, and what have you.
I'm trying to find out. My wife actually got me a gas soldering iron just for that in the field.
Yep.
It's down there somewhere.
I have used those in the past, but if it's windy, if there's a breeze blowing at all, it takes forever for it to work.
Yeah, you just we're quite often in places where there is zero power. So yeah, and I suppose the biggest thing I haven't asked is how much does it cost?
The base aircraft starts for the Pro, which is pre-built 100% and test flown at our facility, and boxed in a nice Go Professional. Everybody likes those GPC cases that everybody gets their Phantoms in and their Inspires in. Well, we have one too. You get all that for about $6,000 US. Then you add on top of that your payloads, whether it be your Sony or your GoPro gimbal or your FLIR Red Edge, and we're going to be coming out with the Sequoia really soon. Once we get some testing going on it, Another one we're looking at is the slant range. We're really excited about that one, and also Centera. So I don't think anybody in our class has the breadth of payloads. It's almost confusing how many payloads we have.
That's a pretty competitive price. I haven't looked at it, so I hadn't thought about it, I must admit. And this is not a product. I'm not endorsing this product or anything like this. I'm just thinking aloud now. But I was expecting you to say it about $15,000, which seems to be where an awful lot of there's certainly a $5,000 or $6,000 class of wing, and then it steps up to 15, 20, 25, 30. 30 is quite a popular price point. That's a very competitive price for something that's made in America, not mass produced, I'm guessing, and certainly not in the, how do you manage it?
Well, we're smart about our resources. We're a small company. We're actually less than 10 people. We build each Pro to order, and in our shop up in New Hampshire, and so. And Adam and I and a lot of the guys, we've been in the industry a long time, and we know where we need to spend money on and where not to spend money on. And so we can pass that down to customers. We don't see the need for a foam airplane to cost $25,000. It just doesn't make sense for anybody to justify that. We were in an industry in the military side where we would sell a little carbon fiber flying thing for $60,000, and it was just silly. So in this market, we believe that we can bring the most bang for your buck. We want to put the money into the sensors.
That's the bit that's working. And so we haven't said what it's actually made of, have we? I don't think.
Yeah. So the bulk of the airframe is injection molded EPO foam. So here you have the wingtip here, and again, this wingtip here has 276 flights on it. And so as you can see, it's just fine. It's actually kind of a rubbery, and it's CA friendly. So if you do break it or crack it, you can just CA it back together in the field. Same with the main wing. So this wing has 270 some flights on it. All right.
And the servos in there, are they digital servos?
Yeah, on the Pro, that's another a new piece that we brought with the Pro is all the servos are digital. So we've gone the digital Elevon servos, as well as the tilt servo in the main airframe is a digital coreless servo. So that tilt is servo controlled then? Is it geared? Yeah, it's actually a chain drive mechanism.
Oh, okay.
So we can see that there.
Oh, yeah.
So we have our tilt servo here. Okay, and a chain and sprocket system.
And I suppose the question I've got to ask now that I've seen that is, have you ever had any failures of it in position or odd position?
Generally, the chain and sprocket is pretty reliable. Over long-term flights and what have you, I've had the typical servo failure. Depending on the situation that the bird is in at that point, you could just revert to the old whatever you were. If you're in forward flight, go back to forward flight and recover the airplane that way. But generally, this is the full disclosure, the most vulnerable part of the plane is during the transition period, where you find out whether this servo has failed you or not. Generally, in flying around, you don't know it. But the tilt servo in Faith, which is this bird, this servo is just recently changed out at after 200 flights. So the transition servo that wasn't here, there wasn't anything wrong with it. It didn't fail abruptly. I just noticed that it started getting a little hot. So, after, what was it, 135 flight hours, I just decided to do a change on it. So
have you got a service intervals for each of the parts, or is
that's part of what this bird is all about? Actually, is to figure out those intervals. The problem is I haven't had enough failures to really come up with a list of things to change. So basically, we can say after 150 flights, change an elevon servo after maybe 200 or 250 flights, change, then now going to the digital servos, that's probably going to get pushed out even longer, because traditionally those are more reliable too than analog. So
soon you should have enough data to be able to say somebody will, you're going to see 150 flights. And then as a business, again, with my shiny new 107 hat on, I can divide the cost by 150 and make sure that's what I put away every flight in order to replace my equipment further down the line. But I think that's, in a lot of ways, that's not a way of thinking of a lot of people in the modern VA world. That's a more manned aviation sort of way of thinking. But
saving up for your overhaul or whatever. But once we get some data put together, that'll be part of our manual and our training, and they will be made aware. Our customers will be aware of anything like that, which is probably more than anybody else does.
Yeah. I've done a lot of work in the ballooning world, and one particular Australian manufacturer is really hated by the other manufacturers because they genuinely do test stuff, and they test it till it's destroyed, and they say, well, it took us this long, and this, and this is how it failed, and which is, it's great, it seems counterintuitive, but the other guys hate it because they can, they can demonstrate. And I'm going to ramble a little bit. They did a really clever thing that's obvious for ultraviolet. They just put a solar cell in the top with a timer. So every time the envelope was in the sun, it counted hours. And in the end, when they had the things come in for service, they could tell whether which particular part of Australia the guys were flying, because in some parts they'd have to get there before dawn and get airborne bang on dawn before the weather arrived every day. So those envelopes had less sun. And then if it was a private owner, they wouldn't rush to pack the thing away, because if you're doing it commercially, you go home, you get the thing packed away and go home. Whereas the private guys, they just, have the champagne, have fun, leave it all left out. So in the end, just from the time of ultraviolet that the envelope was exposed to, they could make quite valuable guesses as to what the end use of the particular, just looking at the logbooks, to hide all the information. And
a little cheat chip.
So they tested a lot of stuff, and that needs to happen in this industry. Unfortunately, a lot of people are inadvertently the testers. The end user.
Adam Sloan, his philosophy, and basically my main job when I'm not doing customer training or R&D stuff is just to fly these birds day in and day out. The weather's good, if the weather is questionable, whatever, I'm still out there flying, because the idea is we want to put time on our internal fleet. I want the bird to crash for me, not the customer. So Faith and a couple other birds I have here that are high time. I got another one hanging on the wall over here that's, she just broke over 100 flights, and she's the one that crashed into the trees on her 6th flight, and she's still going after 100. So the idea is just to find out where the weaknesses are in the whole system, and we can develop mitigations rather than just putting together a kit and saying, okay, Mr. Customer, enjoy it as long as you can, and let us know when it breaks. We'll sell you a new one.
No, that's fantastic. I'm very impressed. We haven't pre-spoken this, people. We haven't. This is all coming live. It sounds like
of my head.
Well, it sounds like I'm sort of bigging you up or something like that. That's very cool. It's very cool that you're doing that. I'm very impressed. So the Y6, not a Y8, not a Y. We're not going bigger. We're staying at this size. Do you think that was because of the previous thoughts that sub 7 kilos was a good idea, or does it just get a lot harder when you get much bigger?
Well, some of that probably goes into Adam's mind. I can't really speak for him as far as why he picked the size. I know this is the 10th iteration and the 3rd version of the design. So it's not like the first one that he drew on a napkin, 5 years ago. It's gone through some changes that, people haven't even seen before. The wings, the airfoil has been validated through computational fluid dynamics, through real science. And so it is the shape and design it is, not because it's the way he wanted it, it's because that's the way it worked out, through research, and that's what you get when you have a product made and designed by someone that's been around in the industry as much as he has, and he's designed, you don't even know them, they're out there, but he's designed 2 or 3 other military hand-launched UAVs. So he's got the expertise to bring it out. As far as the, it is somewhat of a scalable design. Some people ask, why are we using 6 instead of just doing a tricopter with a articulated rear motor, like a normal, like FPV tricopters and what have you. We are limited in the size props that we can run on the front because, there's, as it is, we only have a 1/2-inch clearance between the tips of the propellers and the radius of the front of the wing. So we have played with other props up to 12 inches. We've settled on, we used to do 10-inch props, now we're doing 11. Just found some efficiency gains there. But the Y6 configuration gives us the best efficiency versus the configuration of the bird. You got some of the quad planes out there, they're either 4 motors or 8 motors, depending on how much they're lifting. Some of the great bigger ones are actually 8.
Yeah. Yeah, well, I'm glad you brought that up. Then I didn't have to bring up separate lift thrust, which is the current wonder child of the industry, I suppose. Yeah. A lot of people going that way. You're not tempted?
Well, for the large platforms that we're seeing, like Latitude Engineering has theirs, and then the new one on the block, the Alti transition. Yeah. Those guys are using gas-powered forward thrust engines, so they have to have technology to start and stop those gas engines on command. While they're hovering in helicopter mode, they have no way to otherwise vector their thrust. So I'm curious to see how they will handle winds in excess of 10, 15 knots like we can. Because again, we don't tilt our aircraft into the wind hole position. We tilt our motors. You can't tilt their motors. So it'd be, you get in the smaller ones that have electric separate thrust, they can fire up the electric motor and maintain position with that. So that a lot of the smaller hobbyist quad planes you're seeing are doing that.
So what you're pointing towards? You're pointing towards they're going to end up having to put their wing at some weird angle, and that's going to have some big interaction with whatever the wind is. Exactly.
So in our case, our flight attitude is somewhat like such, right? And so we have a wind on the nose. A normal quad plane would have to tilt into the wind. All right. And what does that do? Creates a negative angle of attack. Now we need more thrust to not just hold position, but to hold altitude. Well, we keep actually our airframe stays at a neutral to positive angle of attack, and we just tilt our motors into the wind to hold station. That gives this design, yes, we have a little bit more complexity in this mechanical tilt system, but that tilt system actually feeds back into our capability for that a quad plane doesn't have. So I think that's where our real advantage is over those systems. Plus the redundancy. What happens when a quad loses one motor?
Yeah. With plainly the quad part of it is going to be an issue whenever you have the word quad. You don't even have to put a plane on it. It's an issue, isn't it? Well, that's cool. I hadn't thought of that. Thank you for walking me through to that very obvious point. Must admit, I had to go at making. Did you see the Delft halfway house quad, which was angled? So when you went to when you transition forward, the motors are angled, and so it just does that as you transition.
So it's like a half and half kind of thing.
Yeah, I thought that was very, very clever for simplicity, because a transition, you weren't having to do anything clever. But what I didn't like about it, and the reason I had to go at it and I didn't like it, the reason I didn't like it was it had no conventional control surfaces on it. If you have conventional control surfaces on it with a wing, that every motor can fail and you've still got a slight chance of getting home in time for tea and medals. No control surfaces, no chance.
It's funny you mentioned that. One high wind landing technique of the Firefly and this isn't specifically for the Pro because we got rid of it, but with the RC controller, you have the capability of flying in the stabilized mode, which allows you pitch control and direct motor control. So you could actually, let's say you got a really howling wind at 20 knots blowing, and even in stabilized mode, traditional hovering is pretty difficult to do. What I've done in the past is actually converted the airplane into helicopter mode, but since our elevons are still active, just as like it's a normal airplane, even in helicopter mode, I can just cut all my motors and just glide the airplane down like I glide any airplane down. And then just before I hit the ground, I ramp up the motors and cushion and flare and land like a helicopter anyway.
So, I think there's going to be a load of, and completely autonomous as well, loads of mixed modes that aren't in people's heads yet, because if you come from physically manipulating stuff, you just can't do it. So you can't get it in a real, I'm talking about a live real situation. So I'm sure autopilots will allow all sorts of ways of controlling things that would just be impossible if you're trying to do it by hand. And
well, that's just the transition in general. I mean, that obviously is the hardest nut to crack on these things, and especially with our system, because we do have a mechanical tilt conversion going on. Everything's about timing, and so a lot of these poor birds met their fate, trying to figure that out, exactly what the timing. And then once we got the timing of everything right, when and how fast to tilt the motors, when to shut off the rear motors, when to restart them, and when you're transitioning back to helicopter mode, all that took hours and hours of testing that we did, and we did all this on our own funding. We have no investors. All right, and we don't have any, rich daddies out there. So, this whole technology has come from our little company here. Our software guy Nate, he's remarkable. He just left NASA, Neil Armstrong Center out there. Is a very smart guy, and he's pretty much the one responsible for AVA in general. They brought us to the single controller flight control system.
So, see, you dragged me into. I have to ask you now: are you waiting for one of the big companies to come and buy you out, and then I can't say so you can retire to Florida because that's where you are?
I'm just an operator. That's a CEO question.
Oh, okay. Hey, good answer. I like that. That's a good answer. That's a very good answer. Yeah. And it's probably a good time. We've been talking for quite a while, but we should probably wrap this up. And I should thank you very much for taking the time to talk to me and walk me through the platform. I'm going to be spending quite a few minutes with YouTube now and looking to see if I can find operators out there in the field, and very interested to see some field reports from it. It looks great. I'm encouraged by what you've said. I'm very impressed with the testing, and I think I want one now. It looks great. So thanks very much, Erich, and I'm sure we'll speak again. Hopefully next time we'll get the other guys. Everyone's traveling and doing things today, but we'll get you back when everyone else is here, because I'd love Gene to talk to you some more. I'm sure Gene would have some very hard questions.
I would really like to sit down and talk again with the rest of the guys. Especially because one of the aspects we want to try and crack into more is the search and rescue arena, first responders and what have you, because I think we have a great platform that can kind of bridge the gap between what they've been doing with consumer quads and what have you into something that has a little bit more capability. But in the meantime, Adam and our guys are at Interdrone this week, booth 1207. So they have a couple of the pros there. Go out there and you can be touchy-feely with them and barrage them with all kind of questions, and they'll be ready for you.
Fantastic. Thanks very much. We'll speak to you again.
Thank you.